This is video 9.3, the Pythagorean Theorem. All right, let's start by focusing on some vocabulary. If I take a line segment and attach another line segment, and they form a 90-degree angle, this is what we call a right angle. Now, if I connect these two lines, I now have what's called a right triangle. All right? Right triangles have special properties. The two sides that form the right angle we call the legs of the right triangle. And the side that's directly opposite of our right angle we call the hypotenuse. So the hypotenuse is the side of the right triangle that is opposite the right angle, which we have here. Now let's look at another triangle. All right, here's my right angle. The two sides that form my right angle we call the legs. And the side directly opposite our right angle we call the hypotenuse. Now usually the hypotenuse is labeled with the variable c, and the legs are labeled a and b. Now, it doesn't matter which leg is labeled a and which leg is labeled b. So for this triangle it would be C, A, and B. So the legs of a right triangle are the two sides of the right triangle that form the right angle. Now, for this lesson we're going to be using what's called the Pythagorean Theorem. The Pythagorean Theorem is a squared plus b squared equals c squared. Now let's look at an animation from Wikipedia that kind of shows us why this is so. If you look here, we have this side of our triangle, which we're going to label A. You'll notice in the animation that if I take side length A and I square it, I get what's called a squared, or the area of a square based on the side length of side A of my right triangle. Now if I look at side B, right here, this is another leg of the triangle. If I make a square based on that length, I get square B, the area of square B squared. So I have a squared and b squared. Now you'll notice that this square in the center here, when it comes back, is based on the C side of my right triangle, or the hypotenuse. So right here, this square is formed by C. And what you can see through this animation is that a squared and b squared is equal to c squared. All right? There is no more or no less of the black area. So this is kind of an animation to show you why the Pythagorean theorem is true. Now let's go back and let's think about that. If I look at this particular triangle, actually let's make a new one. Okay, let's say this side length is 3 and this side length is 4. If this is true, then a squared plus b squared should equal c squared. So if I make a square with a side length of 4, I would get an area of 16. For this leg, if I make a square with a side length of 3, it would have an area of 9, or 3 times 3. Now if I add these two together, so that's my a squared plus b squared, I would get 25. Now what squared equals 25? That would be 5. So if I make a square that's the side lengths of 5, I would get an area of 25. So this square, 16 plus 9, is equal to 25. And that's basically the Pythagorean theorem. Now let's apply it to finding an unknown length. So in this particular triangle, I don't know what C is. Now, before you do anything, you want to make sure that you know where the hypotenuse is. Now, C is a pretty big hint, but if I find my right angle, I know the two sides forming the right angle are my legs of my triangle, and I know the side opposite my right angle would be the hypotenuse. So that's C. So this could be A, and this could be B. So if I take my formula, a squared plus b squared equals c squared, and I plug in the numbers I know, a is 24 squared, b is 10 squared, and that's going to equal my unknown side, c squared. Now let's do the squaring. 24 squared, and remember that order of operations says, or the rule for order of operations always tells you to do your squares first. So we have to do that first. So 24 squared is 576 plus 10 squared is 100. Remember, I can't add those two until I've actually done the squaring. Once I add those, I get 676 equals c squared. And I still don't know what c is. I only know what c squared is. And I need to figure out how I can undo squaring c. What does squaring? Finding the square root. They're inverse operations. So, I also know that 26 times 26 equals 676. So if I have 26 squared and I'm looking for the square root, those are inverse operations, and I would get 26 equals c. So the side length or the hypotenuse of that triangle was 26. Let's look at another example. All right. Here's a leg of my triangle because it's forming the right angle, and here's the other leg. So this must be A. The line, or the side opposite the right angle, would be C. Now I can take my formula, a squared plus b squared equals c squared, and I can plug in what I know. I know that a is 12, so 12 squared plus, I don't know b, so we're going to leave that a variable. And I know c is 18, so that's 18 squared. Again, I need to deal with my squaring before I add or subtract or do anything else. So 12 squared is 144 plus b squared equals 324. Now, my goal is to get b by itself, so I'm going to subtract both sides by 144. And I end up with b squared, because these cancel out, equals 180. Now, how do I undo b squared? Well, the inverse operation is to find the square root. So over here I'm going to have b, and I need to break this down or simplify it. So I'm going to factor it out. 2 times 90, that's prime. 2 times 45, that's prime. Still haven't found any perfect squares. 5 times 9 prime, and 3 times 3. Right, so I can rewrite 180 as the square root of 2 times 2 times 3 times 3 times 5, or 2 squared times 3 squared times 5. Now if you remember from our rules from the last video, I can separate these out and I end up with 2 squared times 3 squared times 5. These are the same. Well, these are inverse operations, so I end up with 2 times 3 times the square root of 5, or 6 times the square root of 5. Now, I usually don't have to write all of this. You can find the pairs, multiply them, and end up with 6 to the square root of 5. But b equals 6 to the square root of 5. And that would be that answer in its simplest form. Now for this next part, we wanted to determine whether the triangle with the given side lengths is a right triangle. So let's think about that. My largest side has to be my hypotenuse, so that would be C. Then it doesn't matter what I label these. One's A and one's B. So I'm going to use my formula again. A is 8, so 8 squared, plus B is 15, so 15 squared, equals C is 17, so 17 squared. I have to square first, so 64 plus 225 equals 289. When I add these two, I get 289 equals 289. Well, this statement is true. So yes, a triangle with these side lengths would be a right triangle. Let's look at another example. Again, I identify my largest side. That has to be C. Then the other two are my legs, A and B. I'm going to use my Pythagorean theorem. A is 5 squared, B is 64 squared, equals C, which is 65 squared. 5 squared is 25, plus 4096, which is 64 squared, and 65 squared is 4225. Now if I add these two together, I get 4121 equals 4225. This is not true. They are not equal. Because this is not a true statement, no, this is not the side lengths of a right triangle. Alright, now I want to look at the lengths of two sides of a right triangle that are given and find the length of the third side. Now, they're labeling A and C, so I know that the side length I'm missing is a leg B. A is 9, so I'm going to write 9 squared plus B squared, because that's the variable I don't know, equals C was 41 squared. I'm going to do my squaring. 81 plus B squared equals 1681. I'm going to subtract 81 from both sides so I can isolate my B squared. So I end up with B squared equals 1600. Now to undo squaring, I need to find the square root. I'm left with B here. I happen to know that 40 times 40, or 40 squared, is 1600. So the square root of 1600 would be 40, and that would be my answer. So side length B would be 40. So this triangle would have a side length of 9, 40, and 41, with 41 being the hypotenuse. Let's look at another example. Here I'm being given A and B. So A squared is 13, so 13 squared. B is 84, so 84 squared is going to equal C squared. So I get 169, again I'm doing the squaring first, plus 7,056 equals C squared. This will give me 7,225 equals C squared. Now I can use my calculator and I discover that this is a perfect square. It's 85 times 85, or 85 squared. So the square root of this is 85, and that's what side length C equals. Now let's apply this to a story problem. All right? A support wire 12 yards long, so here's my support wire here, is attached to the top of a utility pole that is 10 yards tall and is then stretched taut. To the nearest tenth of a yard, right? This is a key phrase, to the nearest tenth of a yard, find how far from the base of the pole the wire will be attached to the ground. So we're trying to find this length here. All right? Here's my right angle, so the side length opposite of that would be C, and the two sides that make up my right angle are my legs, or A and B. So I don't know B in this situation. So I'm going to take 10 squared plus B squared equals 12 squared. I know this is 100 plus B squared equals 12 squared. I want to subtract 100 from both sides so I can isolate B. Oh, I meant to write 144 here because that's 12 squared. I end up with B squared equals 44. Now I know from experience that 44 is not a perfect square. And I need to find the square root of 44. I need to find it to the nearest tenth. Now when I put this into my calculator, I discover that 6.6 would be the answer to the nearest tenth. So it's 6.6 yards would be the measure. And again, this is what we consider an approximation because I rounded it. So B is about 6.6 yards. And that would be my answer. Now the rest of the problems are problems for you to try. There's 3 of them. And this is the end of the video on the Pythagorean theorem.